is Dominic. I'm the head of engineering in BRUSHFAM, and today we will talk about smart contracts, especially smart contracts on Polkadot network. Not exactly on Polkadot, but on Polkadot parachains. So, in smart contracts. Yes. Here I have a little helper. So, first of all, we in BRUSHFAM are developing some tools and products to help developers with Ink smart contracts development. So we are basically Ink smart contracts expert. We have built probably the biggest library for Ink smart contracts called OpenBrush, something like OpenZeppelin for Ink smart contracts. And we are constantly evolving it and making it better, and also maintaining pace with Ink itself, with the Ink language. We also do, since we are the experts in Ink, we also do like Ink advisory for companies, and audits, security audits of Ink smart contracts. But that's just a small introduction about us. How I got into Ink smart contracts, I would like to talk about that, because that's a question. For example, we had Open Advisory Day in our Discord community, where we helped the developers, Ink developers, to answer questions and stuff like that. And there was a question that I thought that it would be like an interesting one to talk about. I myself come from Solidity, but I haven't been working in Solidity professionally. I've been an Android developer before I became a smart contract developer, but started with Solidity and was training some Web3 stuff. Like I was in crypto since 2018 or 17 when the Bitcoin went up and fell. But I didn't leave. I was studying how does it work, and was in the flow. And eventually, we got these DeFi summer, and I don't know what. And I was interested about how does it work, Uniswap, stuff like that. So I started studying smart contracts and in Solidity. And then I wanted to have a job in Web3, and eventually came across this offer to develop Ink smart contracts, and now I'm here. So that's just a little background, my background. First of all, I would like to assess the level of the audience. So, who here is familiar with blockchain? Everybody, okay. So I guess you know what a blockchain is. It's a distributed ledger. Okay, cool. Who here is using blockchain like on some occasion, I don't know, daily basis or? Okay. And who here was developing blockchain? Okay, so that was, I guess, answer to my next question. So who here is familiar with smart contracts? All of you, as developers, and you have experience with Solidity? All of you. Okay, cool. And do you have a professional experience with smart contracts, or just like we're trying something for investigation? Investigation, okay. Okay, cool. So have you also like tried deploying smart contracts to a live network or to some test net?
Yes.
Okay, good. And Is any of you familiar with ink? Okay, and with Rust?
Yes.
Rust. Okay, so my next question would be, why are you here? Any of you can, on this workshop, I mean.
I wanted to learn about ink. This is my first contact with ink.
Okay.
To learn how to go from Solidity to ink.
Okay, so you're interested in moving from Solidity to ink. Okay, cool. So we'll talk about smart contracts in general, Solidity, ink, tools for ink development, but I guess since we have assessed the level of the audience, we can just touch smart contracts and Solidity briefly in theory, and yeah, okay. So this can be more interactive. Who can tell what is a smart contract?
It's a small program that runs in a blockchain.
Okay, yeah. Okay, this is the easy one. Yeah. Here we have I guess you're familiar with this. It's a smart contract in Solidity. I guess you all know what does it mean, yeah? So that we have some mapping of balances, allowances. Everybody should be familiar with ERC20, right? Okay. Here we have something like ERC20. It's PSV22 in ink. Yeah? PSV stands for Local Standard Proposal, which is a standard which was introduced by our team, and it's written in ink and Rust. We will go into the code deeper later in the practical part, but I wanted to show. So we can see some differences, right? Since Solidity is object-oriented language and Rust is more of a structure, functional language with some object flavor, I would say. Then also the contracts look different, because in Solidity you know that every contract is a class, basically, and in ink we did quite differently. So we have some traits which are basically interfaces, and they are implemented with this info section, which is the code. But we will show this later. Then the data structure, that's a structure for the contract storage. And yes, I will, as I said, I will talk about it in deep later. I just wanted to show. Yeah, so pros of smart contracts. Anybody can say something, some pros of smart contracts?
Transactions are recalled in the blockchain.
Anything else?
The code is low.
Code is what?
Low.
Yeah, right. What else?
Usually open source.
Yeah.
Public.
Yeah. So as you say, everybody can see what the program does. Basically, so it's permissionless. Anybody can upload to, but I guess this is things, you know. And it's secure, since, as you said, code is law. Transparent. Okay, and some cons.
It can be insecure, it is not audited correctly.
That's true, that's something else.
Requires a lot of money.
Yeah. It's hard to upgrade
Yeah,
once the smart contract is in the blockchain. Make that credible can be a challenge.
Yeah.
And some of the concepts can be hard to digest.
Yeah. Yeah. So, yeah, it's permanent. There is a human factor, but I guess that's in every application. But since smart contracts are revolved around money a lot of times, can be a bigger threat, I would say. And we have no connection with the real world. But I think everybody knows how can we connect with real world, like
Oracle.
yeah, with oracles. And permanent is also not that big problem in the past, since we have these upgrade patterns. I guess you know some upgrade patterns of smart contracts. Proxy and something else. There's also diamond standard, something like that. And so how proxy works? Anybody knows how does proxy work? Yeah, okay, cool. So proxy contract is a pattern on which basically delegates calls to another contract. So one contract is the contract of which we are calling, and it delegates its calls to another contract on the blockchain. So let's say if I have a method transfer in one contract, contract A, can I use this?
I guess. Yes, you can use.
Okay. I hope that you will see.
Maybe może być nowy.
Yeah.
Nie
Okay.
jestem żadny.
Okay. So proxy contract. We have proxy. It's one contract. This is deployed on chain, and it has a fallback function. Anybody knows what the fallback function does? In Solidity, it executes code when no selector matches the function of proxy. So let's say that it has no functions. This contract has no functions. If I call function A on this proxy, it sees that it doesn't have. Let's separate it like this. Yeah, I will do the call A to the proxy contract, and it doesn't have the function A, so it will go to fallback and it will do something. And what proxy does is that it will in fallback call this selector on some other contract. So let's say we have let's say contract A. Let's be creative. Yeah, contract A. Also proxy has to have some field like implementation, which is address of the contract that we are delegating the calls to. So we call function A on proxy. It doesn't have selector for A, so it will go to fallback. And in fallback, what we will do, then it will try to call the function A on implementation. Implementation will be, for example, contract A, and it has function A, so it will execute this function. If it doesn't have function A, it will revert because we try to, it will go to fallback. Yeah. It will not revert, but we can program it so it will. How do we upgrade? That's maybe a question that you might ask. And we can upgrade by, let's say we will have set implementation with address as parameter, and there we will just override, let's say we deploy new contract B, which has the A function, and also we want to add function B, and we will just override this implementation to contract B, and now when we call function A, it will go here, and we can also call function B. So this is one way how we upgrade contracts in Solidity, and we can also do it in Ink. So this is in general. Was that clear? Yeah. Okay. Do you have any questions? If you have any questions, you can. Okay. Also, one limitation that we didn't mention in cons. Anybody knows? Can you upload like 20 gigabytes of contract? Okay, you cannot. So there is a limit to how big the smart contract can be. In Solidity it's 24 kilobytes, I believe, and in Ink it's 128 kilobytes. But this can be also like we can also bulk around this a little bit with another upgrade pattern, which is diamond standard. Yeah, and anybody knows or has some,
I think it's a standard that lets you create like unlimited smart contracts. Like what it does is each function like treats it as a little smart contract, so that you can have like an unlimited big smart contract. Something like that.
Yeah, something like that. I will start with a picture. This is a diamond, and it has these parts which are called facets. And why is it called diamond standard is because we can remove and insert these facets at some time. And this diamond standard, it allows us to upgrade contracts and also have basically unlimited smart contracts, because we have this one diamond standard contract, that's the main contract, and it contains let's say addresses of the implementations of contract. Okay, this is not exact, but this is just imagination, because it's a bit more complicated. But I will just give you an overview of how does it work. Yeah, so we have some addresses of the contract that we want to call. So like in proxy, we want to call this implementation, but in Diamond Standard we have multiple, and we have them mapped to function selectors. So also there is this fallback function, and anytime somebody calls a selector which is not in the Diamond Standard contract, it will look up to which address it's registered, and it will do a delegate call to that contract. And delegate call doesn't, but no, what does it mean? Delegate call?
it's used color as the collie. I don't really know how to explain the file using like what you are calling. You are using your own storage, but with the function of the
Yeah, so delegate call, if contract does delegate call, it works with the storage of the called contract and of the calling contract and with the code of the contract that we are calling. So, yeah, and that's how it works. Proxy and daemon standard. And in daemon standard we can add, remove, replace these selectors and facets. So that's how you can upgrade contracts and have unlimited contracts. This is for Solidity. It's also for ink. We have these standards implemented in OpenBrush in our library. But these are not working currently because we have to re-implement them for newest ink. There was a big change in ink, and we have to also apply these changes to these proxy and daemon standards in OpenBrush. But in ink there is also another way to upgrade contracts, and that's via function setCodeHash, which is so that's ink specific. And that's a smart contract function which just overrides the code hash of the contract. So yeah, code hash is the hash of the code of the smart contract, I guess you know that. So this is possibility in ink to upgrade. One thing you have to make sure when you are working with upgradable contracts is that you are using the same storage keys all the times. So how it's done in Diamond Standard is that, or I will talk about in general. So contract storage is basically mapping from key to some value. Yeah? And every time you initialize the contract, the storage can be different. But when you use the same storage keys, then it will be not different. I will show that in the practical part. This is just something to remember. Use the same storage keys. Yeah. So applications, I guess you can name some.
Every sector is applications for smart contract.
Aggregator?
No, in every sector.
Yeah.
I just like for example for logistics, like they use smart contracts for the transparency, the blockchain. To follow the products.
okay, maybe for an action to pay for something.
Validate some documentation, for example, for legal purposes.
Okay. Landing. No application of smart contract. Do you have some application of smart contract?
For insurance,
Yeah. Anything basically. Taxes, where I mentioned gaming, multi-sig contracts, which is a good way of usage for big money. yeah, fungible, non-fungible tokens, but okay. So Solidity, you are all familiar with. So I guess you all know that it's an object-oriented programming language, has static types, supports inheritance, libraries, and has user-defined types. Okay. Let me check my cheat sheet. Okay, yuck. This was something that interested me, the history of smart contract, that it was first mentioned by some guy, I don't know what's his name, Sabo or whatever, in 1994 or 84, and his vision of smart contract was a digital vending machine. And basically with the right inputs, a certain output is guaranteed. Yeah, I also had the code, but I think I don't need to show it since it's a more advanced audience. Bless you.
Bless you.
So, structure of a smart contract, right? What can it include? What do we have in smart contract? Functions, constructor, modifiers, events, state variables. We also can have some struct types. Yeah, enums, anything basically. Yeah, the main parts are functions and storage variables, so we can call the contract and store its state. Okay. This is not necessary. Not necessary. Okay. So let's talk about ink a little bit. Oh, yeah, Alina is happy. What is the difference between Solidity and ink? Yeah. So first of all, ink is an embedded domain-specific language on Rust, which means that it's based on Rust, and basically it's runs the macros for operating with underlying blockchain with pallet contracts. As you can know, how many of you are familiar with Polkadot and Substrate? Like how is Substrate blockchain?
I'm glad you should talk about it.
Okay, so you know that there are frames and pallets, stuff like that. Yeah, one of those pallets is, what do I have here? Okay, yeah, one of those pallets is pallet contracts, which basically enables these smart contracts on a particular blockchain. And what ink does, it generates the code, which is needed for communication with the blockchain, with the pallet contracts frame. Yeah. So there is also one thing I would like to talk about, but since you are all interested in smart contracts, I guess that it might not affect you, but it's a little background, because Polkadot was not originally created for smart contracts. Polkadot was meant for You can come, you can create your frame, you can create your specialized blockchain for whatever you want with Substrate, build it everything, mix it everything together, have a new blockchain, connect it to Polkadot, have like interoperability and whatever. No smart contracts. Why would you need smart contract when you have a tool for doing whatever you want? But there is a little problem that if you want to create your own palette or your own specialized palette for something, I don't know, maybe for decentralized exchange or whatever, it might require a bit of time since creating a palette is not like that. We have Substrate, it's easy to use, but you are going to write some specialized code, and then when you deploy a solo chain or own parachain connected to Polkadot, you still need users. And why would users come for just one use case to your blockchain when you can be on Ethereum, Polygon, Binance Smart Chain, Solana, I don't know, whatever, and have more liquidity and have anything, not just one use case. So a lot of times, there are use cases when your use case might be good as a palette, like as a separate blockchain, but it's always better to create an MVP as a smart contract, and then you can find out if it works, if it doesn't work. So smart contracts are the possibility and the way, and Ink makes it easy to build smart contracts as well. Okay, this is a comparison of Ink versus Solidity. So with Solidity you need EVM. No, you don't need, you will just write the code, compile it and run it, deploy it on the blockchain, but it runs on EVM, virtual machine. Ink can run, since it's awesome, WebAssembly, since Rust compiles to WebAssembly, that means that Ink also compiles to WebAssembly, and you can run it on any WebAssembly virtual machine. Yeah, Solidity is, there is also one con of Solidity. Why I like Ink more than Solidity is that Solidity is created solely for the use case of smart contracts, and it's a bit young language, and it has a lot of limitations just because it's meant for the smart contracts. On the other hand, Ink, since it's based on Rust has a big community. Rust is meant for low-level programming, for safety, efficiency, speed. So I also think that Rust will be the future of smart contracts, either with Ink or with something else, but it will be Rust. And Solidity is very easy to learn, since it's I would say JavaScript for smart contracts. It's relatively easy compared to Rust, for example, but when you have the right resources, it's also easy to learn Ink and Rust. There is the safety thing with Rust, that the compiler, a lot of things which might be an error in Solidity, like a critical bug or critical safety issue. A lot of those things are caught by the compiler of Rust. So we have the safety thing. In Ink you can have multiple constructor functions, which I don't think I have used it, but it's a nice thing to have. We will show that. Yeah, Rust since Rust is not only for smart contracts, Rust is basically for anything. You have these tooling, basically anything that supports Rust. Versioning, not important, metadata we have in both. Multi-file project, as you can see in ink it's bland, but OpenBrush lets us, OpenBrush, which is the library that we are developing, it lets us to have multi-file projects. Yeah, in Solidity you have only 256-bit storage entries. In ink it's a variable, so you can basically save on storage. And yeah, I guess that's all. Do you have any questions?
So since we are using WASI in Solidity, when you publish a contract in Ethereum or Polygon, you can always read the contract. What about with ink? Can we still read the contract, or is kind of encrypted by WASI?
Yeah, it's encrypted, but you still when you have the Solidity code, you can only read it if you have it like you mean like read it on Interstream or something like that, yeah. You can only read it if you have the original source code. So someone has to verify it, provide the original source code, and it has to match with the deployed bytecode. And you can basically do the same with ink, with BRUSHFAM. If you provide the code and provide the compiler options that you have used, you can basically get the same bytecode. Sometimes you cannot, because there are some things like some procedural macros in Rust which may then differentiate the output bytecode. But for this, we are developing another tool that's called Patron, which I will mention as well in the practical part. And what this does is that it lets you deploy your code, your ink smart contract, and it also compiles it for you on the server. So we have the code hash, we have the original code, and that means that we can post the verified code on our front end, and people can read it. So, but it's possible to, if you provide the same code, the same compiler options and everything, most of the times you are able to produce the same awesome block. So basically the same how you verify contracts in Etherscan for Solidity, for example. Yeah. Are there any questions? Okay. Okay. Yeah. So in ink we have these kind of attributes, which are basically attributes or macros which make the ink smart contract. Because as you will see, it's always just Rust code with some attribute, with some macros like this, which give it the functionality of a smart contract, which can communicate with the palette contracts. So we have ink contract, which basically tells that a mod or a mod file is an ink contract and gives it all the required functionality. Ink constructor, that is an attribute that we add to functions which we want to be constructor. Ink event, That's an attribute that we put over a Rust struct, which will be an event which can be then emitted. Ink message, I'm just talking about those that you will need. We will see it in the practical part. Ink message is an attribute that we put to functions, Rust functions which we want to be callable from the contract. So basically public API. Payable is an attribute that we put to payable messages, so functions that can receive not Ether but some native currency. Selector, we can put to messages to override its selector or to define it by ourselves. Storage we put to structure which will serve as the contract storage. Topic, that's for events, like if you have in Solidity indexed, that's with this attribute it will tell that this field in the event is indexed. And chain extension, yeah, that's one beautiful thing about ink, which I always have to say how much I love it. And that's one advantage over Solidity. In Solidity you have a smart contract, you can call the smart contract, you can maybe call other smart contracts from one smart contract. Maybe if you have a bridge, you can somehow get your funds from one chain to another chain, yeah. But ink chain extensions is probably the most beautiful thing about ink. Anybody has an idea what could it do?
Does it work like a bridge?
Oh, sorry?
Does it work like a bridge over other chains?
Yeah, we can say something like that. It goes far beyond that, because chain extension, it lets you to use the functionalities of the underlying blockchain directly in the ink smart contract. So you can call functions of, for example, of the blockchain that your contract is deployed, and do whatever you want. Like whatever the chain allows you to do, you can do it with chain extensions. And since we are in Polkadot and we have XCM and multi-chain and whatever, you can basically call chain extension to do XCM message from Astar to Pendulum or to whatever chain you want. One thing that I have to mention here is that the chain extension has to be implemented in ink, like the messages of the chain extension have to be implemented on ink side and also on substrate side, and have to be implemented directly in the chain. But most of the times it's done, and for that we have another tool that we are working on, and it's OBCE, Open Brush Chain Extensions. So yeah, this is a cool thing to mention. So, ink storage. I think I will use the table. Or maybe not. structure which contains all the data. So for example in Solidity, if you have like 20 fields around the contract, here you will have it in one struct. We will show that. I believe. Okay, I should show this first. And I will show it here. And then I will talk about the storage, so it's more understandable. So this is the vending machine I was talking about. It's in Solidity. This is code from Ethereum.org, I believe. So how does a vending machine work? I guess you all should be familiar with this code, but let's see how does this look like in ink. For this, maybe there's Sol2ink. Okay, so this is Solidity code, and here I should have the same code as in ink. Yeah. So this will be the comparison of ink contract versus Solidity contract. So as you can see, constructor we have here, and in ink this is the storage field. Yeah, this is the storage field. So here we have owner, cupcake balances as the two storage variables, and in ink it would be one struct which would be annotated with ink storage, and there we have all the data. Here we are using another attribute from OpenBrush, which allows us to build multi-file projects, and I will show that in the data we indeed have what we need. Yeah, so here we have the data struct. Owner is an account ID, and then cupcake balances is a mapping from account ID to U128. So these contracts were done by another of our tools, which is Sol2ink, which allows you to convert Solidity code into ink, but it's still a work in progress, so it still doesn't create fully compilable contracts, but it should save you a lot of time. As you could see that I have just convert this in 1 second to have an ink code to show you. So yeah. So yeah, this is the storage struct as I was talking about, and here we have implemented the functions. So refill. If you are asking why does it have so much code, that this Solidity only has 2 lines and here is like 10 lines, that's because we are not doing reading and writing in the same time. So here, for example, cupcake balances address this plus equals amount. Here we first get the value, increment it by the amount, and then we set it. Yeah. So this is a comparison from Solidity. Okay, any questions? Do you want to ask something about this?
Only one question in ink. The data structure is everything inside one data. Okay, if you could show. So you only can create the struct data, and then inside it you create any variable that you want.
Yeah, I will clarify this because I will close this. Yeah, because this is the contract. This is the contract itself in ink. Yeah, we have the storage struct, vending machine contract, and we have implemented a trade vending machine for vending machine contract. We can basically take this code, these functions, and put them here in the contract. But if we want it to be tidy and clean, we will separate it into multiple files. And that also means that we want to have this data struct declared here, yeah? But you can basically add there if you want, I don't know, maybe counter for transactions, you will add counter in 128. Yeah. And maybe, so do you know what trades are in Rust? Okay, I heard, I saw, I cannot see words. Yeah, I have heard one yes, so that means that maybe I will talk about trades a little bit. Yeah, I can show it on this.
I have one question. The data field is required? It has to be called data, or how do you call it?
You can call it anything you want, but it's Sol2ink calls it data on every time. So yeah. Okay, I will explain about this generated contract. Yeah. So before we had one file, vending.sol, and now we have like how many files? I don't know. For one contract, you don't really need like this kind of structure, but if you have, if you had something like exchange or something like that, it is better to have it structurized and have your code structurized. So in Rust, we have something that's called trades, and trade is trade vending machine. That's basically an interface of the an interface in Rust, and in ink it's just a description of the functions. So as you can see, we have refill, purchase. They are annotated with ink message, and this one is ink message payable. And the trade is annotated with OpenBrush trade definition. I will explain this in the practical part. But here we have the trade, and that's in trades. Yeah. Currently we have only one trade, so it could be in one file, but if we add more, it would make more sense. But Sol2ink doesn't make differences if you convert one file or 10 files. It will always create a good structure for you. Yeah, so this is the trade. Then in OpenBrush we also have something like wrapper, which creates a reference to your trade and allows you to do cross-contract calls with ease, and we'll explain that as well. And then, so you just take the code, take the function, and implement it in the way that you want. Yeah, so this is the implementation. And what this says, that it will implement vending machine with this code for every type that inherit or implement storage data. And now you may be asking, what is storage data? And that's a trait which is created by upgradable storage macro from OpenBrush, and it has like this generic type. So that means that if we have in our contract this data input data storage field, what this does, it will implement storage with this data to vending machine contract. And since it implemented it, if we call impl vending machine for vending machine contract, it will pick up this implementation. Yeah. Any questions?
If you return an error, it's like if reverting the contract, the transaction, will you return an error?
Yeah. It will revert. Yeah. Yeah, and that's basically how ink transactions end. You either panic or return error. But if you return error, then you have more descriptive errors, and you are able to tell what happened in the front end. So we tend to return error, but you can also use assert macros. If you assert false, that will panic. You can call panic.
Yesterday, if I understood correctly, we were told that you should not use panic in software.
Yeah.
It's considered a bad practice.
Yeah. Yep.
So it's better to return the error.
Yes. Yeah. That's what I'm trying to say. There are possibilities, assert, panic, whatever, but as I said, when you panic, you don't have the exact reason what happened. You just get like internal error or something like that. So yeah, and it's always better to return error. The transaction will revert in any way, so better to return error than to panic. That was true. Okay. Okay. So that was example of code of ink. I will show more stuff in the practical part, but just wanted to give an overview. Are there any questions? Maybe you want to ask something or clarify something?
In the table where you compare Rust with Solidity, you show that BRUSHFAM has multiple constructors. And what is the function that you can have while having multiple constructors?
Yeah, I will show it. So here, for example, this is our vending machine contract. We have function new, which is annotated with ink constructor. That means that we can create an instance of this contract by calling it new. But I can do this, say new 2, creativity, and here I will insert 200 instead of 100. And now if I call new 2, it will create the instance with 200, not with 100. So this is how you have multiple constructors in ink. But to be honest, I have never used it. But it's a possibility. Anything else? Okay. Did you have a question? Okay. Okay. What tools are there for ink? First of all, but it's the last one, is use.ink. That is a website, you can check it. It contains documentation, explanation about everything that you will need in your ink smart contract. It's done by the Solidity team, by the ink team. And use.ink is also a name of a newly published front-end tool. So yeah, you can get anything there. Then another tool which is kind of essential for ink smart contract development is OpenBrush, which is developed by us. We are basically pioneers in the ink space because we have been. Our team is the author of the first standards for smart contracts, for ink smart contracts like PSP22, which is basically fungible token in ink. PSP34, which is a non-fungible token standard for ink. PSP37, which is a multi-token standard for ink. We have created this, and we have also pushed the development with OpenBrush and with our partnerships. So yeah, and OpenBrush, what it contains, it is a library which contains all the smart contract standards for ink, and also some macros which make the development of ink easier. Yeah, we will definitely use it. Then we have Patron, which is our newly published tool for deploying smart contracts and the verification of smart contracts. And it's still an MVP because it's 1 week old, but it already does its job. But it's still not that extensive like Etherscan, for example, but we will get there. We are very new space and early to this space, so still a lot of work to do. And we have Sol2ink, which is another of our tools. And what it does, as you could see before, it converts Solidity contracts to ink. And little backstory of Sol2ink. We have been working on transforming one Solidity application into ink, and it was taking a lot of time, a lot of repetitive work, like create a Rust trait from Solidity interface, stuff like that. So I took a 4-hour break and wrote a little transpiler which did this in less time, so I could save some time on rewriting the basic stuff like rearranging the attributes and I don't know what. And now we have Sol2ink, which converts all Solidity files to ink. It still has some bugs, and maybe you can find some errors, but they are all described on our website, which I will also show, and it still saves a lot of time. Yeah, so these are the tools, and also communities where you can discuss your ink code. We have a Discord community, BRUSHFAM, where there are a lot of ink smart contracts developers and asking questions. We try to answer them most of the times. If I don't sleep. We have Element group, which is also the same in Telegram. Well, it's a metrics group, and it's accessible via Element or via Telegram. Alina can then give you ways, links how to connect to these. And also there is Substrate Stack Exchange. I don't know if you have heard about it yesterday or so. That's basically a Stack Overflow for Substrate, which maybe 5 months ago had no ink tags or one per month, so I was able to answer all of them, but today I cannot follow it anymore because there is a lot of new ink developers, so yeah, that's also possibility. And yeah, I think that will be the end of the theoretical part. So you can try to check out on Twitter. Also, there's my Telegram if you have a question. I think I will show this once again, or you can follow me better. And yeah, do you want to say something?
Yeah, I just wanted to mention that Dominic talked about the community that we have. Why we actually mentioned it right now in this workshop, because the Discord that we have, it contains like different channels. So for example, when you as a Solidity developer start your way with the ink smart contracts, this is the place that you should, like our Discord, you can enter and ask whatever questions that you have about the ink smart contracts, and our, like all the best experts, all developers will answer and provide you some help, because it's definitely needed for the ones and for the new people who are entering this space. And of course, if you are going to use the Sol2ink or the OpenBrush or TypeChain, anything, you can just, I don't know, like mention Dominic, for example, there in the chat, or other our developers, and all information will be provided. You can even share the bugs that you have with your code, and everyone will check it and will send you how to fix it, how it should work, etc. So that's why I will share with you the link of our Discord, and it's definitely going to be super helpful.
Yeah, and the thing is that it's not only us developers from BRUSHFAM, but it has evolved into a community where other developers I think also answer. And
there's also guys from the Parity who are sometimes answering, also from the S-Star, from the Alex Zero, from the Kala. So basically everyone will be trying to help you with that.
yeah.